Hello and welcome everyone. In the last lecture, we have seen question number 6 and question number 7. In today's lecture, we are going to solve question number 8 and question number 9. So, here we have question number 8. In this question, we have to find the points of discontinuity for the function f of x is equals to modulus of x upon x if x is not equals to 0 and 0 if x is equals to 0. So we have this function. First of all, if you can observe this, we have to write this function again. Why? Because we all know that modulus of x has two values. It has minus x when x is less than 0 and plus x when x is greater than 0. So because of this, this function has also two value. Modulus of x upon x has two value. One with x less than 0 and other with x greater than 0. So first of all, with x less than 0 and x greater than. So let us write our function again. So we can write f of x is equals to so we can write our function again. F of x is equals to, we have three values. First is minus x upon x if, let me write minus x upon x which is minus 1 if x less than 0, x upon x is equals to 1 if x greater than 0 and 0 if x is equals to 0. Now the given function f of x is defined at all the points in real line, right? So we can take any point C from the real line. So let C be any point in real line. C be any point on the real line. Now we have three cases. Our point C is less than 0, our point C is greater than 0, and our point C is equals to 0. So let us start with case 1. Let C less than 0. Let C less than 0. So if C is less than 0, f of C is equals to, what will be f of C? It is minus 1 because f of x is minus 1 when x is less than 0. Here as you can see, f of x is minus 1 when x is less than 0. That's why f of C is also minus 1. Now let us find the limit. So limit x tends to C, f of x is equals to, limit x tends to C, f of x is equals to limit x tends to C minus 1, which is equals to minus 1. So here you can see that our limit and our function both are equal at c. That's why we can write it as, therefore limit x tends to c f of x is equals to f of c. That's why f is continuous at x less than at x less than 0. So f is continuous at x less than 0. Now let us check for x is equals to 0. So if we are selecting a point which is c is equals to 0, now our second case is if c equals to 0, then f of c is equals to 0 as our function is defined. For all x is equals to 0, f of x is 0. So when c is equals to 0, f of c is 0. Now let us check left limit and right limit of a function. So first of all, limit x tends to 0 minus f of x is equals to minus 1. F of x is equals to limit x tends to 0 minus 1, which is equals to minus 1. Here you can see that these two are not equal. So from here we can say that this function is not continuous. But let us check left limit also, the right limit also. So limit x tends to 0 plus f of x is equals to limit x tends to 0 plus 1, which is equals to 1. So here limit x tends to 0 minus f of x is not equals to limit x tends to 0 plus f of x. That's why we can say that the function is not continuous at x is equals to 0. So f is not continuous or you can write f is discontinuous at x is equals to 0. We can also say that x is equals to 0 is point of discontinuity, right? Now our third case is if our point c is greater than 0, then f of c is equals to 1, because f of x is equals to 1 for all the points which are greater than 0, right? So that's why f of c is equals to 1, and let us find the limit of the function. So limit x tends to c f of x is equals to limit x tends to c 1 is equals to 1. So as you can see, f of c is equals to limit x tends to c f of x. That's why the function is continuous at all the points which are greater than 1. So here we can write limit x tends to c f of x is equals to f of c. So let me write it here. Therefore, f is continuous at x greater than 0. So for all the points which are greater than 0, our function is continuous. For all the points which are less than 0, our function is continuous. But for x is equals to 0, our function is not continuous here. So we can say that x is equals to 0 is point of discontinuity. So we can write, therefore x is equals to 0 is the only point of discontinuity of f, is point of discontinuity. Why this is point of discontinuity? Because at x is equals to 0, our point is our function is not continuous. So this is question number 8. And now let us move to question number 9. So our question number 9 is f of x is equals to x upon modulus of x if x is less than 0 and minus 1 if x is greater than and equals to 0. We have to find the points of discontinuity, all the points of discontinuity for this function. So first of all, we have to rewrite this function. It is same as the question number 8, but the difference is we have given here if x is less than 0 and if x is greater than and equals to 0. So now let us write the function again. So f of x is equals to, now if x is less than 0, we know that modulus of x is always minus x. So we can write this function as x upon minus x, which is equals to minus 1, right? This x and this x could be cancelled. These two could be cancelled. So 1 upon minus 1 is minus 1. If x less than 0 and minus 1 if x greater than 0, greater than and equals to 0. Now if you observe the function carefully, in both the cases f of x is equals to minus 1. So we can simply write our function f of x is equals to minus 1. So this is a constant function, right? This function is a constant function. So we can take any point C, let C be any point let C be any point in real line. So we can write f of C is equals to minus 1 and limit, let me write it here, limit x tends to C f of x is equals to limit x tends to C minus 1, which is equals to minus 1. So as you can see, our f of C is equals to limit x tends to C f of x. So we can write it here, limit x tends to C f of x is equals to f of C. Therefore f is continuous. Therefore f is so we can write f is continuous at every point in real line. Therefore there is no point of discontinuity. For this function. So this is question number 9. In this question we have no point of discontinuity. So that's it for today. We will see our next question in next lecture. Till then, goodbye and take care.